Hello and welcome, student. Before we start solving previous tests and exams, I would like to make this important disclaimer. The following will be just a practice exam, and it's only intended for revision purposes only. So it has nothing to do with your actual exam. It is not a model for your exam. It's just for you to revise, to test yourself, to practice more, keep yourself with a timer, be in the exam environment. You shouldn't assume the actual exam will be identical to this one. It's also crucial before you start viewing this review is that you complete all the homework problems, look at the lecture notes, and watch the previous video to ensure a thorough preparation for the exam. This is only a practice exam. It's just for revision. It will not help you understand the material. You need to do the homework, lecture notes, watch the videos before you come and see this exam. Now I will start solving this final exam of Calculus 3. As you can see, it has 5 questions. Some of them are multiple choice question. Look, if we go to the first question, it's only the multiple choice question. I'll leave this one to the end. What I will do first, I'll solve the written part. So let me start with the first one. As you can see here, we use Lagrange multiplier method to find the points on this line that is closest to the origin. Now, if you remember, when we say the word closest, it means the minimum distance. So here I'm looking for the minimum distance. But the distance between what and what? It will be the minimum distance between the point that I need to find, which I don't know what it is, I will call it x, y, z, and the origin, which is given by the coordinate 0, 0, 0. Now, what is the function that find the distance? It is the function with the big square root of x minus 0 square, y minus 0 square, z minus 0 square, which in short is just x square plus y square plus z square. Remember, if we solve a question about minimum distance, we don't need to do the minimum of the square root. We can just assume my function I need to minimize is this one, the one without the square root. And now I have a constraint, which is this one. So we have a function and we have a constant. Of course, there is one thing here that we need to specify in the question. I did it in 3 dimension, but of course this one is in 2 dimension. So I'll just leave the z part away, just to be consistent with what is given in the question. It should be specified in the question that this is 2 dimension, but here anyway, we will just assume it's 2 dimension because we have constraint out of 2. Okay, so what's Lagrange multiplier method? It says that you find fx and make it equal lambda gx, find fy, make it lambda gy, and then you write the constraint, which is the relation between x and y, the same. Now, as for the first equation, you will find that 2x equal to lambda times, what's the derivative of g with respect to x? It's only 2. Second equation will give me that 2y equal lambda, and what is the constraint? It's negative 4. And finally, you just write the equation as is. Now, as you can see from the first equation, I can say that x is equal to lambda. Second equation, I can say that y equal to negative 2 lambda. And why would I take the third equation, which is this one, and let me substitute x with the value of lambda. That's an easy way to find it. So we have lambda, negative 2 lambda. Now what we have is 2 lambda plus 8 lambda equal to 3. So lambda equal 3 over 10, which means x is equal to 3 over 10, and we have the y equal to negative 6 over 10. And here what we get as a result. Of course, since we are using Lagrange multiplier method, and we get this is the only answer that we have here, and that will be the point which has the minimum distance. So the point is 310, negative 6 over 10. That's the point. Of course, what we need to do is we need to make the table, find what is the maximum and minimum. Of course, because it's a distance, we're only looking at the minimum distance, and that is the point. Now, if we go to the next question, which is number 2, I'll leave this one to the end because this we need, you know what, let's do it here. So we'll just have to screenshot this one. And let me do it in a new page. So the question is, find or use the triple integral of the solid enclosed by 2 paraboloid. Now we have to sketch the 2 paraboloid. We'll try our best. The first one, the one in red, will go upward because it's a paraboloid upward. The second one in orange, it should start at 6 and it will be downward. So you have 2 paraboloid, one of them upward, one of them downward. And that's what we get. And we need to find the triple integral. Now, in order to find the triple integral, we need to see which variable to start with. And the easiest one is to start with z. Why? Because if somebody is inside the region, the top will be the orange and the red will be the bottom. And that's the easy one to start with the z. So the first thing that we have here is that the top is the orange. And then we have the bottom, which is 5x squared plus 5y squared. That's the easy part. We finish from the z. So if we go to my final answer, which I will write it in the second page so that we don't mix things up. If I go to my final answer, the first integral I will do is dz. What should I write down? I need to write down this one. What should I write in the top? Is this one. Now we have the other integrals which we need to do in terms of what is x and what is y. So this one here. Now focus on x, y. Now focus on x and y. What do you mean if I say focus on x and y? We need to do the projection. What will happen inside x and y. Now, imagine, to find the projection, as usual, imagine somebody is standing here and he's looking downward. What he will see from his point of view, he will see only the big circle that is the intersection between them. Because if we just do a projection, what we will get circle, and the biggest one will start from here all the way to here. So if we focus on x and y, we need to find the intersection between them. What do we mean by intersection? The z in red must equal the z in orange. Now the z in red is the paraboloid 5x squared plus 5y squared. The other one is x squared minus y squared, and there is an equal between them, which if we just simplify it, it will be x squared plus y squared, or 6 equal to 6, which means x squared plus y squared equal to 1. And that's what will happen in 2 dimension. We'll just have a circle of radius 1. Now, how do we find an integral where we have a circle of radius 1? We change into polar. So r between 0 and 1, theta between 0 and 2 pi. So we go back here and do the integral from 0 to 1, integral from 0 to 2 pi. And now we have to do dr d theta. Of course, this integral has to be rewritten in a better way because everything must be now between r and theta, dz, dr, d theta, and this here we have r. This will be just 5r squared. Why? Because x squared plus y squared is r squared, and the top one will be 6 minus r squared. And now all what we need to do is we need to evaluate this integral. The first integral r dz is just rz, and we substitute 5r squared, 6 minus r squared. The next, if we substitute, this will be 6r minus r cubed minus 5r cubed, so it would be just 6r cubed dr. I'm just doing here quickly, this is just the evaluation of the integral. So this will be just 3r squared minus 6 over 4. And now we just substitute 1. We get 3 minus 6 over 4. And the final answer will be just 2 pi 3 minus 6 over 4. Which is, in total, it would be 3 pi. And that's how we find this integral. Next question, again, we need to take this integral and change it into polar coordinates. How do we do that? First of all, we have to write the region. That's the region. All what I know is y between 0 and 1, which means my region will be only here in this area. Keep this in mind. Second, x between 0. So my region will be only in this area because x is 0 above and between 0 and 1 is this one. So we have only this region. Finally, we need to know what is this. Now, in order to know what is this, we write x equals square root 1 minus y squared. If we square both sides, we get 1 minus y squared. So we get x squared plus y squared equal to 1, which is a circle of radius 1. Now, this circle of radius 1, I should only draw the part in this region here, and that would be just this one. Now, if we change it to r and theta, this would be from 0 to 1, and theta is clearly between 0 and pi over 2. Take all those information and put them in the question. So the integral would be from 0 to 2 pi, 0 to the pi over 2. Integral from 0 to 1. Cosine, what shall we write inside? It will be just r squared. And then we have r dr d theta, which is now is an easy integral. This is just substitution. So the integral will be half sine r squared. We substitute from 0 to 1 d theta, which if we do it correctly, it will be just half sine 1 2 pi. The final answer would be pi sine of I'm here quick finding the integral, but you get the idea of how do we find such an integral. We will go now to the next question. Which is one of the questions that we always like, is the green theorem. The question says, evaluate the above integral using green theorem. So we'll have just to write the formula for the green theorem. But in order to find for the green theorem, we need partial q by partial x minus partial b by partial y. This is the region, is very easy. It's just the unit circle, which has radius 1. But it says oriented counterclockwise, so it will go like this. Now, if it's counterclockwise, this is the correct formula. You start with x and then start with y. How do we find such double integral? Well, first of all, we take the second one, which is x, differentiated with respect to x, we get 1 minus. Take the first one, differentiated with respect to y, again we get 1. And that's give me 0. So the green theorem is give me 0. Second one says evaluate the above integral directly without green theorem. That means evaluate it as line integral. What do you mean line integral? It means take this L, which is y dx plus x dy, and substitute y in terms of t, dx in terms of t, x in terms of t, y in terms of t. So we need to do parameterization. We must say x equal what in terms of t, y equal what in terms of t, and t from where to where. How do we do parameterization? We look at the curve itself. It's a circle. And for the circle, we know how to do parameterization of the circle. One of them will be cosine, one of them will be sine. Which one will be cosine? The one that we start with. So we start with x and we go in the direction of y. So this cosine and this is sine. And the t will go from 0 to 2 pi. Take those information, let's put them in the integral. The first y is just sine t. Dx is the derivative of x, which is negative sine t, plus x, which is cosine t, and then the derivative of y, again cosine t dx. This will give me just integral from 0 to pi cosine square t minus sine square t dt. Now cosine square, sine square, you can do the half angle formula for each of one, and the final answer will be just 2t. I'll just do it quickly here. So the integral will be just half sine 2t from 0 to 2 pi. Substitute 0, substitute 1, again you get 0, which is expectedly we get the same answer. Either we do it directly or we do it with the green, we get the same answer. Remember, this kind of a question, we can do the same for Stokes theorem. We use Stokes theorem to find the double integral. We use the line integral, which means take x put in terms of t, and you find the same answer supposedly. Last question here is we have to use the component test to show that this vector is conservative. Now this vector has x, y, z, so the easy way to do it is to use the curl. If the curl, which is the gradient of f cross the gradient cross f, if this is equal to 0, it means conservative. Let's try it. Partial by partial x, partial by partial y, partial by partial z, and then we write the function here. 2xy z cube 3xy squared z squared. And then this has to give me three answers, one with I, one with j, and one with k. Now, if we delete the column of I, row of I, and do the cross, this will give me just 4xy z squared. Let me write it down. 4xy z squared minus, if I delete this one, this one. Now, if I do this one, again, it will give me 4xy z squared, which is the same. Next one, delete the column of j, the row of j, and do the cross. If we do that, it will be 3y squared z squared minus, if we do this one, it will be again 3y squared z squared. Finally, we go to the one with the k and the row of the k. If we do this, we will get 2y z cube minus, if we do this one, we will get 2y z cube, which is 0, so it is conservative. Next question, we need to find the potential function. That I need to go to the next page and do the question. If I go to the next page, this my f capital was what? Y squared z cube, comma, 2xyz cube, comma, 3xy squared z squared. Now, the first thing here, in order to solve this question, remember that fx equal to the first component, which is y squared z cube. That means f by itself is equal the integral of this one with respect to x, which will just give me x y squared z cube plus g of y comma z. Next equation is fy equal the second one. Now, what is fy? Take this one and make a derivative with respect to y. You get 2xy z cube plus the g of y equal 2xy z cube. That means g of y equal to 0, which means g of yz is only function in z. So there is nothing with respect to y. How to find g? I didn't find g yet. I go to the third equation and I write fz equal the third one, which is this one. 3xy squared z squared. Is it z squared, y squared? Now we find the derivative of f, which is 3xy squared z squared plus g prime of z equal 3x squared y squared z squared. And now we cancel. So g prime of z equal to 0, so g of z equal just c. So the final answer is this one plus a constant z. So if we just write it down here, the potential function will be x y squared z cube plus a constant c. Finally, we need to find the integral, which we use the idea of endpoint minus f of start point. So we substitute in f 203, and then we substitute in f 102, which is, if we do it correctly, if we substitute, because the y is 0, we get the answer is 0. Why is that? Because if we substitute y, 0, and then we have just 0. And those are the written questions that we have. Next, we'll go to the MCQ questions. We solve them as we go along and check if our answer is correct. Let's go to the first one. Identify the quadratic surface, which is z has power of 1, x squared, y squared on one side, and both of them positive. So this is our favorite shape, which is elliptical paraboloid. Hyperboloid, this must be a minus between them. Ellipsoid must all of them positive, all of them in one side. Elliptic cone, it means z must have a square. Question number 2. Find the point at which the line with parametric equation, I have the equation, intersect this plane. So you have a plane, and then there is a line intersecting the plane. So the idea is we substitute x, y, z inside this equation. So we will get 4 minus 2 plus 5 equal 18. What should I have filled those? Instead of x, I write 2 plus 3t. And instead of y, I write 5 plus t. And finally, we just write negative 4t. And now we just do it. So here we have 8 plus 12t minus 10 minus 2t minus 20t equal 18. Take t's together. 12 minus 2, that's minus 10, minus 20, so we get minus 10t. Take the numbers together, we have equal to 20, so t equal to negative 2. Of course, none of these answers is negative 2 because he wanted as a point. So we substitute t equal negative 2. So we get 6 minus 2 is 4, and that would be definitely the first answer. No, we have to check the others as well. So no, not the first one, unfortunately, no. It will be this one. Yep. Next, we need to find partial y by partial x. And if you remember, there is a formula. We find the derivative of x in the top, derivative of y in the bottom. What's the derivative of x? Is 3x squared plus 6yz with a minus sign. What is derivative of y? I think it's the same except this one. Now, which one of these is the correct answer? Of course, he already simplified the 3 and 3. So it will be just x squared over y squared. This one. Next question, find the value or values of a where this vector is perpendicular to this vector. Perpendicular means if we do the dot product, we get 0. Let's do the dot product. We'll get a squared plus 6 minus 5a equal to 0, which is a squared minus 5a plus 6 equal to 0. If we do it mod 5 for 3, a will be 2 or 3, which is this one. Next, it says find the work done by the vector field, and I give you the parameterization of the curve. So what shall we do? We just need to write f dot dr, which is integral of p dx plus q dy. What is p? It is x minus y. What is q? It is x plus y. Now, all what you need to do is do the parameterization. So the integral will be from 0 to 1. And instead of x, you write minus t. And instead of y, you write 1 plus t. Derivative of x is negative 1 plus. Now, if you add them, this is just 1. Derivative of y, again 1 dt. which is will be the integral from 0 to 1 minus 2t plus 2, which will be minus t squared plus 2t. Substitute from 0 to 1, the answer would be 1, which is this one. Now, this is, of course, the level curve. Level curve means we write this function equal to the number that we want it to be. So in this questions, I'll just leave this one for the level curve. Go to the gradient. Gradient means just find the derivative, and the derivative of x is just yz exyz. Same thing for y. It will be xz exyz. Same thing for z. It will be just xy and then the e. Why? Because you take the derivative of the e is the same, and then you find derivative of whatever inside. Now you just need to substitute those numbers in each one of them. So the first one, if we substitute, of course, all the e's will be just 2. Now, for the first one, it will be minus 2. For the second one, will be minus 2. And for the third one, will be just 1. Which one has this shape? Minus 2, and 1. It's C. Finally, let the function of unit vector for which is the minimum directional derivative. Remember, directional derivative, the minimum is at the gradient. If you want to make it unit vector, you divide by the gradient. Now, which one is the gradient? It's this one. Focus that the first one has a minus, the third one has a minus. So the gradient is just derivative divided by the units. Last question is, we have a double integral and we want to change dx dy. In order to do that, we have to sketch. If we want to sketch, first of all, notice that y was between 0 and 1, and x, it was between 4 and 4y. Now, where is x equal to 4? This is x equal to 4. This is this one. Y equal, or x equal 4y. This is just a line going like this. And y between 0 and 1, of course, this will be 1. So this is my region. Now I want you to change it into type A, type 1. Type 1 means x between two numbers, which is clear from 0 to 4, and y between top and bottom. What is the bottom is 0, what is the top is the function in red, but you need to write it in terms of x. So the integral should start from 0 to 4. That means the first one is out of the equation. And then the second equation should start from 0. That means b is out of the equation. And then it should be end up at 4 over x, which will be just part D. Thank you for watching. Now, what happened in this exam, we solved all the questions. Of course, there are some topics we didn't talk about, like absolute maximum or local maximum, local minimum, and so on and so forth. But there is one important question that was not in this exam, which is Stokes theorem. So what I will do now, I will just put for you a couple of videos to watch about Stokes theorem, just to complete the picture, because Stokes theorem is a very important question in every calculus. Hello student, and welcome back to Stokes theorem in Calculus 3. In this video, we would like to verify Stokes theorem for this vector field over the surface S. So if we have to verify Stokes theorem, first of all, if we write Stokes theorem as it's given to us, so this is f dot dr by Stokes. This is the same as the double integral, so we transfer a single integral over the boundary over any surface S that has the boundary C with curl of f dot ds. Of course, in this example, we have the surface S, so we know exactly what we need to do. And in this example, we need to calculate the double integral separately, and then we need to calculate the single integral separately and check if the two answers are the same. Now, if you have watched part one, in part one, we calculated a line integral for a different question. In part two of the videos, we calculate the double integral. So in part three, we'll do both. So I would like to advise you to do two things first. If you didn't watch part one and part two, please go and watch them, because everything here in this video is just similar to part one and part two, but it's combined. Second, after you watch them, pause this video and try to solve this question by yourself. Find the first one, second one, and then play the video and make sure that the answers are identical. So I would suggest, because we just finished from part two, and I assume you just finished watching part two, I would suggest that we start with the double integral. So number one, we will find this integral. Now, in order to find this integral, if you remember, this would be the double integral over a region of the curl of f dot, we need to find the parameterization for this particular surface using u and v. So first step, we will find the curl. Second step, we find parameterization and we find the derivative and the cross product. And then we will transfer this integral into a double integral and we will solve it. So let's do the curl of f, which will be the cross product between the gradient and f. If we do it as matrices, it would be something like this. And finally here would be minus 2yz. This is the first component of f, and then y, and then 3x. If we just look at it again, just to ensure, yes, 3x, y, and okay. Now, if we find this one, of course, first we have to cancel the row and the column of I. If we do it in the usual way, this is something in I minus something in j plus something in k. Now for the I, if we cancel the row and the column of I, what is left is derivative of y for 3x is 0, derivative of z for the y is 0, so the first part is 0. For the second part, derivative of 3x with respect to x is a 3, derivative of negative 2yz with respect to z is negative 2y. So what we will get is 3 plus 2y. Finally, for the k, if we cancel the column and the row of k, this will be 0 and this will be just negative 2y, and because there is, so this is just 2z. And that's the curl. So first we find the curl. Now the next step is we will go ahead and we will try to find parameterization for our curve. The best way is we have a small sketch here. The surface S is elliptical paraboloid. It will start at 5 and will go down to 1, something like this. So if we do the curve here, it will be like this. That's my surface, which is z equal 5 minus x squared minus y squared, and it is part of z is in the plane z equal to 1. Now, the best idea to have the parameterization is, since I have, let me just write it down here. This one, I have one equation, 3 variables, then 2 of the variables can be any 3 variables we choose, and the best one we choose them are x and y. The reason why, because if x is u, y is v, then z will be easily found to be 5 minus u squared minus v squared. This is the parameterization, and from this parameterization I can find r, which is u, v, 5 minus u squared minus v squared. So what is RU and what is RV? RU will be 1, 0, minus 2U. RV will be 0, 1, negative 2V. And next, we need to find the cross product. So if we find the cross product, will be 2U, comma, 2V, comma, 1. And of course, the last step, we need to find the curl times this one. So the double integral S curl of f dot RU cross RV dA. This would be just double integral. Now for the curl of f, it is negative 3 plus 2y, and we multiply it by the second because it's 2v. Remember the curl starting with 0 and something else, so we just start from here, plus 2z with the third one, which is 1. And of course, this one would be double integral d. Now, if we return everything back to u and v, this would be negative 3 plus 2u times 2v plus, now 2z will be just 2v dA, which is, if we just simplify it here, would be, this will be negative 6v plus 2v. This would be just negative 4v. And this one will be just 4uv. Which is something we can handle here. Oh, I'm sorry, I think I did a mistake here. The 2z, the z is 5 minus u squared minus v squared. So there's a mistake here. I can just cancel this one here and go back here. So this would be what? It would be 10 minus 2u squared minus 2v squared dA. So this would be just double integral of negative 3v, negative 4uv plus 10 minus 2u squared minus 2v squared. Or just let me, just for simplifying things, I will take negative 2 as common here. So it will get u squared plus v squared. Now we need to find this integral, so we need to find the region between u and v. Copy. Paste it here. And now if we just see what is the region. Now if we look at u and v, we will find out that it will be like this. And this is the... Now, what is this exactly? This will be, of course, if we go back to z equal to 1, that's where we'll have the biggest circle. That means 1 equal 5 minus x squared minus y squared. So this means x squared plus y squared equal to 4, or similarly, u squared plus v squared equal to 4. So this is a circle of radius 2. And for the double integral, this will just turn out to be using the polar coordinate into 0 to 2 pi. So this integral will be 0 to 2 pi, 0 to 2. And now I have to change everything into the polar coordinate. So the first one will be minus 3r sine theta minus 4. So it would be 4r squared sine theta cosine theta plus 10 minus 2r squared. And then don't forget there is an extra r here because I'm changing to polar coordinate, dr d theta. And this integral will be 0 to 2 pi, integral 0 to 2. Now if we distribute the minus, it will be r squared sine theta minus 4r cubed sine theta cosine theta plus 10r minus 2r cubed d theta. If we do the first integral with respect to r, this will be negative r cubed sine theta, negative r power 4 sine theta cosine theta plus 5r squared minus 2 over 4 r4 from 0 to 2. If we just substitute 0, everything will be go away. So just we need to substitute 2. So we'll get minus 8 sine theta, negative 16 sine theta cosine theta plus 20 minus 8. D theta. Which is, if we just continue with all the calculations, the one that we will get is the following. If we do all the calculation, the answer should be, if we continue and everything is correct, we can just do the integral here. This will be 8 cosine theta minus, this can be function with derivative, so it will be sine squared theta over 2 plus this will be 12 theta from 0 to 2 pi. And if we do the calculation, now substitute, this will be just 12 times 224 pi up here. I'm sure, I think I did some mistake somewhere here. I think the mistake is it would be 10 minus 2u squared minus 2v squared. Plus 10. Okay, I think I know where's the mistake I did. It's from the beginning. The mistake is here. This one should be just V. So we have to change this one into V, this one into V. So this would be cancelled. This would be square. This would be square. This should be square. This should be square. And now the integral would be a little bit different here, because this has, we have to change it into, this one would be 8 minus 8 cosine 2 theta. So that's how it would look like. So it will change into 8 theta plus sine 2 theta, and here 4. Now if we do this one, what we are going to get, 12 minus 8, so it will be just 8 pi. And that's the answer for the first one. Now, let's check if our answer is correct by doing the opposite. Now, what we will do is we finish from this one. We know the answer is 8 pi or 8 pi. Now we need to find the integral straightforward and check if the answer is correct. Number 2, we will compute the single integral directly. So it means we need to have the curve itself. And remember, what is the curve? If we just talked about it here. Let's look like this. The curve is this one, this circle, which means z is 1 and x squared plus y squared equal to 4. So if we do the parameterization, we would use 2 cosine t, 2 sine t, z equal to 1, and of course t should be between 0 and 2 pi, and we assume it is counterclockwise. So if we just do the integral now, before we do the integral, let's find dr. So we have r of t equal 2 cosine t, 2 sine t, 1. So dr would be just negative 2 sine t, 2 cosine t, and 0. So the integral dr would be just the integral from 0 to 2 pi. And now we have to do the dot product between f and dr. So if you remember f, it starts with 2yz. We have to multiply first with first, so this would be 2 sine t. Second with second, it was, if we just go back to, it would be just y. 2 cosine t. Of course, third with third, we don't need to do it because it's already 0 here. 0 times anything would be just 0. Next step, put everything back in terms of t. So it would be 2 times, what is y? Y is 2 sine t. What is z? Z is just 1 times 2 sine t plus the y. What is the y? Would be 2 sine t times 2 cosine t, of course, dt. Now we work with this integral. It will be 0 to 2 pi. This integral will be minus 2 and 2. It would be 8 sine squared t plus 4 sine t cosine t dt. We almost can do this integral, so just let us use the double angle formula. This would be 4 1 minus cosine 2t plus 4 sine t cosine t dt. And now this integral, if we do it, it will be 4. What's the integral of 1? It's t. What's the integral of cosine? It is sine 2t 1 over 2 plus, now this one, sine function and its derivative. So all what we need is to square it. So it will be 2 sine squared t, and we substituted 0 to 2 pi. If we do it just by calculator, the answer will be 8 pi, which is exactly what we needed. It is the same as predicted by Stokes theorem. The answer is 8 pi. By solving those three, part 1, part 2, part 3, I wish everything has been clarified now about Stokes theorem. Thank you very much for watching, and please try to solve as many questions on Stokes theorem as possible. Welcome back, student, to part 2 of solving exercises using Stokes theorem. Before we start solving this exercise, I would encourage you to pause this video and try to solve the exercise by yourself, and then play the video and compare your answer with the answer in this video so that you can get the benefit of solving the question and checking your answer. So in this example, we need to find the line integral FDR using Stokes theorem. So we have to invoke Stokes theorem. We shouldn't solve this one directly. Of course, sometimes we can solve this one directly, but in this exercise, we need to use the Stokes theorem. I have the vector field F, and I have the boundary curve, which is C, or the curve that is circle in the xy plane of radius 2, centered at the origin. So let's first of all write what Stokes theorem is telling us here. Stokes theorem telling us that f dot dr, it is the same as, of course this is using Stokes theorem, this is the same as the surface integral S for the curl dot the surface that has the boundary which is exactly the same as C. So this is what we need to find here. So the best idea, first of all, let's find the curl, get rid of it, and then we come back to this integral and we try to evaluate it. So let's do the curl of f. So the curl of f will be just the gradient cross product with f, and if we do it as determinant, this is I, j, k, and here I have partial x, partial y, partial z, and in the last row I have to write the function itself, so it will be minus yx squared, the f, as well as xy squared, and e xy. And now we just need to find this determinant. So first we cancel the row and column of I, and we do the cross product with the negative. So first we have to do the derivative of y to this function, and what we will get is this. It will be directly x e x y. Why? Because derivative of y to this function, x will go down, e will stay e, and the derivative of xy squared with respect to z is 0. Second one, if we cancel the row and the column, if we do this one, this will give me y e, and this one again will give me 0. So the second part will be y e x y. Now for the third one, if we do the derivative, this is y squared minus will be y squared plus x squared. This is the curl, we just want it, and we just keep it as is. Second is we need to find a good surface that has C as a boundary surface. So let's go here and evaluate the situation. Of course, what I have here is this is a circle of radius 2, something like this. Okay, so this is 2, this is 2. And now I need to have a surface which has the boundary as the circle. So we can think about it as hemisphere, option number 1, hemisphere. If you don't like hemisphere, maybe you can have half ellipsoid. And we did this in part 1. The question part 1 was half of ellipsoid. We can have elliptic paraboloid. It could be, for example, cone, and anything. Now, each one we have to try. Maybe some of them would be easy to evaluate the integral. Some of them would be also difficult to evaluate the integral. So what I will choose in this example, I will choose S. So let S be the plane, or let's say part of the plane in the xy inside the circle. So instead of going up and then I take the surface, I'll just take this part, which is again a surface. It's called S. The boundary of the surface is the circle. So this is something legitimate that I need and I can take. So that's S. Now you need to find parameterization for S. And for the parameterization, we need two parameters. So the parameterization will be x equal u, y equal v. And of course, because I'm in the z is equal to 0, I will just keep it as 0. Of course, we have that u square, v square will be less than or equal to 1 because I'm thinking of inside the circle. And that's the suggested parameterization. Now, in order to find the integral for this one, which is the double integral s curl f dot ds, of course, here we will have to have double integral over the region of the curl of f dot ru, derivative with respect to u, of the parameter, derivative with respect to v, dA. So what we need now to do is we need to find ru, rv, we need to find the dot product, and then we will get an double integral that we can solve it separately by all the methods that we have. So let's find ru, rv, and then cross product, and then we will do the dot product with curl of f. So if I go back here, I can find ru will be, of course, r of u comma v. This one just u, v, 0. Ru will be 1, 0, 0. Rv will be 0, 1, 0. So Ru cross Rv, this will become very easy because now Ru is I. This is J. You can find the cross product between Ij and it will be just K, which is 0, 0, 1. Of course, you can do it as determinant, but that's what you should get. The next step, we need to do the dot product between 0, 0, 1 and the curl. So if we do the dot product between 0, 0, 1 and the curl, if we do the dot product, the only term that will survive is the u squared plus x squared. So here what we will get is equal double integral of y squared plus x squared dA. Of course, we have to write it down in terms of u and v. And this is just v squared, u squared dA. Now, what we get, let me just write it down here. This is double integral, usual double integral that we can find by knowing what type of region do we have. Of course, the region, we already did it here. And if I do it again, it will be just v, u, it will be just a circle. A circle. So if we have double integral over a circle or a part of a circle, the best idea was, as usual, to use the polar coordinate. And for that, r will just go from 0 to 2, because here we have the radius 2, and theta will be from 0 to 2 pi. So if we just transfer this to polar coordinate, this integral will be from 0 to 2 pi, integral from 0 to 2. Now v squared plus u squared, this will just give me r squared. So I get r squared. And then there is an r extra because I'm using the changing to the polar coordinate. So I will get this integral here of r cubed dr d theta, and the integral of r cubed just 1 over 4 r4 from 0 to 2 d theta, and this will be just integral from 0 to 2 pi. If we substitute 2, this will give me 4 d theta, so the final answer is 8 pi. Now, of course, there is one thing that we need to keep in mind is the orientation. If we assume we have a positive orientation, we keep the number as is. If the orientation is negative, then this answer has to change into negative. However, in this example, we have a positive orientation. The reason why we have positive orientation because the circle is going counterclockwise, as well as the RU or V is going upward from my region. So this is my region, and this is the normal going upward for it. And that's how we solve this question. Please, in part 3, which is the most important one, because in part 3 we'll use Stokes theorem again, but we will find this one separately, independently, and we'll find this one independently, and we will verify that the two answers is the same. So please stay tuned to part 3.